So univariate data, that is what we did last week. Univariate data is data in one variable. So like the data that we did last week, it had temperature problems, but it was temperature for like one city. Okay. Or we were talking about like how different people got their news. Okay, the different ways they could get it, either print, online, or new books, or old books, stuff like that. Bivariate data is data with two variables. So again, it's like I said earlier, it's like boys and girls doing the same thing, and you put them together. Okay, your book describes it as data with pairs of values. That's how your book describes it. Okay. All right, now for this one, there's only a whole, was it 4? Yeah, there's only 4 things for bivariate data that you're gonna use. Okay, so two-way tables, we did that last week. From two-way tables last week, they are what type of data? Anybody have a guess? Categorical or numerical? It is categorical. Good, Christiana. Okay, so it's categorical. Okay, so it is categorical, and it's a table that shows, you can say the book says classified, or you can say like categorized data in rows and columns. I do want to ask a question. Which way do rows go? Good, sideways. And columns go? Good. All right, just want to make sure we know the difference. Okay. All right, so good things that a two-way table can do is it displays individual points or single points. Like you can see exactly where all of the numbers go and who had the most, who had the least, stuff like that. So next bit, it shows frequencies of data classified by 2 categories. Because remember, it's bivariate data. Bivariate means 2. And this is categories, so it categories. I can almost spell. There you go. Did I spell it right? No, I did not. Gosh. And it can compare categories and subcategories. The one bad thing that it does is it can be difficult to see trends, like what are patterns in your data. Because all you see is a bunch of numbers. You can't really see it like on a graph, like over time. So it's hard to figure out what happened when and what's going to happen later. Okay. So again, just to go over what that looks like in your book. So when it says the categories and subcategories, like for kids and adults or for chocolate, kids and adults, they both like chocolate a lot. Now, out of the category for chocolate, who liked the most? Kids or adults? Adults. So chocolate would be your category. The subcategory is who liked it the most. Okay? And then again, like the showing frequencies is how often did something happen. So you can see out of the kids which type of candy the kids like the most, and out of the adults you can see which kind of candy the adults like the most, or who had the most votes for something. Okay, that is something you can see in all of them. Okay. All right, a segmented bar graph. So just like an idea, a segmented bar graph looks like that. It's a bar graph where you're going to put those two different things together. So like this table up here, how again for kids there was chocolate candy and fruity candy. We put it together in one bar graph. So again, for kids, only a little bit of them liked chocolate, but a lot of them liked fruity candy. So that's why it's split into two different colors. It's split up by chocolate and fruity candy. Same for adults, it's split up by chocolate and fruity candy. That's a segmented bar graph. It's a bar graph where it has like two pieces of data in the one bar. So, according to your book, the definition was, they call it a stacked bar graph. So again, you stacked one piece of information on top of the other for the same category. And again, that is used to display categorical data. Okay, because we display the different categories of the different types of candy that each person liked, kids or adults. Okay, and in that stacked bar graph, each bar equals 100%. So each bar equals 100%. Because again, when you're looking at it, you were looking at all of the types of candy that kids liked, or all of the candy that adults liked. So, good things that a segmented bar graph can do. Good things. It shows how a category is divided into subcategories. You could see that kids, you could see the chocolate percent and you could see the fruity candy percent. You can see the two different colors really easy. And you can use it to compare categories. And it does one bad thing. The one bad thing is graphs with many categories or subcategories can be hard to read. Because if you put like 50 different bars on there, that's a lot of information. You only use this for a couple of pieces of information. Questions about those ones? No. Okay. All right, next one, scatter plot. You should all know what a scatter plot is. We've already done them in this class. Okay, a scatter plot. What do you think? Is that numerical or categorical data? It is numerical. Okay, because it's just dots on all of the different numbers. So a scatter plot is a graph representing data as I can almost spell as ordered pairs. Okay, so good things that it does is it displays individual points, because that's literally what it is. It's a scatter plot. It shows you every single dot on the graph. And it is easy to see changes or trends. Or no. It's easy to see trends. But it's difficult to see changes between data points. Okay. The last one is a line graph. Okay. All right, a line graph. Do you think that is going to be categorical or numerical? It's numerical. Okay. And then a line graph, you use it to display numerical data. You're using connected line segments. On a graph. Okay. So again, if you're not sure, it looked like this. Okay, that is a line graph. So you have a bunch of dots and you use lines to connect them to show what's happening with your data. Okay, the difference between this and a scatter plot, you do not connect them. Okay, so again, scatter plots, you don't connect them. Line plots, you do connect them. Okay, that's your big difference there. All right, so good things that a line graph does. Okay, let's see. Good things is that it's easy to see changes between data points. Like, remember those lines that you would draw on it? The lines tell you if you went up or went down. So you can see what's happening. And it's useful to show how data changes over time. And you can display individual points. What do you think would be a bad thing? Graphs with what? Graphs with what kind of data? Or what would you not want to graph? Huh? Yep, I don't want to graph a lot of stuff. That would, like, if you had 50 different data points, you'd literally have to make 50 dots and 50 lines, and no thank you. So graphs for large data. It's hard to read, because that would just be confusing. Now, the catch is they gave you all of these different things, these 4 different things. You have to know how to make them. So guess what we gotta practice? Making them. So you've already learned how to make a scatter plot, and a line graph honestly isn't that much different. Okay, the one that we really want to focus on is a segmented bar graph, because that's the weirdest one. Okay, so that's what we're gonna try, and then if we have time, we will practice a line graph, because that is what is on your homework as well. So step number 1, okay, to make a segmented bar graph, they almost all start with a, what was this called? What is this thing? A table, specifically a what kind of table? It's a two-way table. Okay. So you learned how to do two-way tables last week. We did that on Friday. So now you're just practicing what you learned. Make sure you got it. So this two-way table is all about gym member preference, data for endurance, strength, balance, and flexibility. So they already gave you all of the numbers. You don't have to fill in that bit. But we do have to figure out the what? Percents. because you have to be able to answer the question. We need to determine which exercise has the greatest percentage of males, which I'm sure you can figure that out looking at the table, okay? But you still need to figure out what the actual percentage of that is, okay? So to figure out a percentage, like what do you do with this 7 to find the percent? Divided by what? Divided by 100? Why would I divide it by 100? So remember, we're thinking about this. We want a segmented bar graph to show, what is this one word right here? Gender percentages. So when I'm looking at the gender percentages, I want to know how many girls voted for this out of all of these. So you're going to use these totals on the bottom, okay? So I need you to divide that one by 20. And then you still have to multiply by 100 technically, but so it's what percent? 35. Good, Ava. Okay, now we need 13. Again, we're going to divide that one by 20 because we're looking at the total people that did endurance. Okay. And then if you do the total, 20 divided by 20 should be how much? 100%. So again, your total should always be 100% for these since we're going down. All right, now look at the strength column. For strength, how many people voted for strength? No, 50. So we're going to divide our strength column by 50. And this is the part where I strongly recommend, please actually try dividing these to make sure you know how to get these percentages. You have to do this exact same thing on your homework. So if we're not practicing it now, that's probably not good. Okay. All right, 5 divided by 50, we get 10. So 10%. So 45 divided by 50, we should get 90. And then 50 divided by 50 is 100%. All right, what are we dividing balance by? 20. So 17 divided by 20, we get 85. 3 divided by 20.
15.
And then 20 divided by 20. 100. All right, flexibility. What are we dividing flexibility by? 40. Good. So 38 divided by 40, we get?
95.
Good. And then 2 divided by 40. It's the smallest percentage. Yep, 5%. And then 40 divided by 40. Good. Now to make the segmented bar graph, do you really need this totals column right here? No, not really. It's honestly just practice to make sure you all know how to find percentages. So just to make sure, we would divide 67 by what?
130.
The 130. And we get what percent?
51.
Well, let's see. I got a 5 after mine, so that 5 would make the 1 do what? So it would be a 52%. So then 63 divided by 130 should be
48.
And then 130 divided by 130 is 100. Okay, now, how many different categories do we have for the exercise thing? 4. We don't count the totals. Okay, so we only had 4. So you see your little chart thing down here? See it's got 4 little lines on the bottom? Guess what those are for?
To label them.
To label that. Okay. So however you want to write it, I'm just gonna go like this because these are, some of them are big words. So we're gonna have endurance and strength and balance and flexibility. Okay. Now, who was voting for all of these? Men and women. So, guess what your segmented parts of your graph are going to be? Female versus male. Who voted for a what? But we have percentages that go up to how much? 100, because our biggest one is 95. So we kind of want to label this up to from 0 to 100. Okay, so I think you have enough room. You can count by tens, I believe. 10, 20, 30, 40, 50, 60, 70, 80, 90. Yeah, you can count by tens. Okay. So this is the percentage. Now, normally when you do a segmented bar graph, you're gonna need like 2 different colors. What you can do, because you're gonna need like a key, because like you remember in the example how they use blue and purple, where blue was for chocolate and red was for fruity candy. You need something like that to figure out like the females versus males. So if you want, like, you can use one where you color it in and one where you don't. So you're gonna need to write that key somewhere so that we know what we're doing. So for the key, so if you want female, can be the non-colored one, and then male can be the colored one, or you can flip it around, or you can make one of them polka dots instead of colored in, or if you have highlighters, you can use your highlighters. It is up to you. However you want to make that work best for you. So let us start. So endurance for females. Females were what percent for endurance? 35. So we're going to make our bar graph go up to 35. And again, you're just going to kind of go in the middle and just kind of go with that. Okay, so that was female. Okay, and you normally want to write the percent in there so you know what it is. Okay, so males was how much? And that should go all the way up to what?
100.
Yep. So you just kind of color it like that-ish. Which again, hopefully yours looks better than mine. And then do the exact same thing for strength, balance, and flexibility. So for strength, the women had a whole 10%, tiniest little bar. So men had to be,
90.
and that's gonna go all the way. Yep, because 90 plus 10 makes 100. Okay. Do the same thing for balance. flexibility. Whew, it's a tiny little bar. So for the flexibility, if you can't fit the 5% inside of the bar, because I do understand it is very small, you can write it on the side, kind of like this, and say, oh, that's 5%, and color it in like that. So based off of your graph, they wanted to know which exercise had the greatest percentage for males. So which one did males pick the mostest? Strength. And they had what percentage? 90. And again, you do have a question just like this in your homework. Males picked strength. They had 90%. What was the highest one for females? Flexibility. Okay, they had 95%. Okay. Alright, so questions about how to make a segmented bar graph. Because again, you do have one just like that in your homework. And I gave you the same stuff. I gave you that little, I filled in the table with the little percentage thing so you can fill it in, and then I gave you the little blank graph. So that should help. Alright, last one. We are going to make a little plot, and we'll see what it looks like. So when you read that one, let's see, Christiana, what does that one say? Alright, so we need a data display to show how the data is changing from year to year. And we are talking about men's basketball championship games. So these are, let's see, those are the number of points scored. So what do you think would be the best way to do that? First of all, is this data numerical or categorical? Numerical, because it's a bunch of numbers. Okay, and are there really any categories to it? No, it's just years and points. That's all it is. Okay, versus the last one where we had different things we were voting for, and males and females. This is just how many points did you get each year, period. That's it. Not a lot going on there. Okay, so let's see, for numerical, from your front side. Let's see, that means it should be a scatter plot or a line graph. So basically, should we connect the dots or not connect the dots? We're gonna connect them. So that means we need to make a line graph. If you weren't sure about connecting them, they gave you a little clue here. Describe how the data is changing. So when you looked at a line graph, a good thing it does is it's easy to see changes. Okay? It's easy to see changes, and it's useful to show how data changes over time. So line graphs are better at that. So that's why we're going to use that. Now, here's the hard part. Let's see, the years. What does the years go from? 2010 to 2019? Okay. And then the points, what's the lowest amount of points? And what's the highest amount? Okay, so we have to figure out how to do that. So I tried to give you a graph with a bunch of lines on it. So where do you think years is going to go? The bottom or on the side? Nope, it's going to be on the bottom. So we're going to do years on the bottom, which means points are going to be on the side. Okay, so for years, you can kind of just count by what they are. Okay, and you can do something that's called breaking the graph. So to break a graph means you don't start at 0. So what that means is you put a little squiggle thing right here. That means you're not starting at 0. Because, right, the years go 2010. Okay, so you can just say like 2010, 2011, 2012, 2013, all the way to 2019. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 12, 13, 14. Yeah. I don't think it will fit. Okay. So let's see. So there's our years. Now for points. We basically need to go from like 0 to 162. What do you think you should count by? Let's see. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We have 20 boxes. Joy. Yeah, you can count by tens. That would be the best since we do have to go like to 4s, 6, 8s, 1s. So I would suggest counting by tens. So 10. Again, if you wanted to, you could break the graph again and start like at 90 down here. But then you'd have to count by something else where tens is just easy. Cool. Thank you. And then all you gotta do from there is plot your points. So at 2010, we had 120 points. So let's start at 2010, 120. That was right here. 2011, we're at 94. So you're kind of there-ish. And remember, you want to connect the dots because it's a line graph. So do your best to draw a line between each one. 2012 is 126. So that's a little over halfway. 2013 is 158. So just under 160. 2014 is at 114. So just under half. 2015 was at 131. 2015. 2016 was at 151. 2017 is at 136. 2018 is 141. 2019 is at 162. So you should have something kind of looks like that, hopefully. If it's not perfect, that's totally fine. I don't expect it to be. That's a lot of dots. It's a really small graph and hard to graph some of those numbers. The main thing you should be able to see is what happens. So the display shows that the number of points scored has what over time. Go up, go down, stay the same. What happens to your dots over time? Are they always the same amount? No, okay? So the display shows, yeah, you can say that it changes over time, or they like to use the word varied. because you know it's variation, it doesn't stay the same. It's varied over time. And between 2010 and 2019, the maximum number of points scored was 162. Okay? And that's what you're looking for. So again, you have a homework page, you're doing the exact same thing. So some of them you have to make a graph. So you have a bar graph you have to make, and it'll be a line graph or a scatter plot here. And then the rest of them, you just have to figure out what would be the best one to use. What would be the best one to use for each of those? Okay.